Welcome to This Explainer. Today, we're cracking open the 2026 premium edition of Forensic Medicine to look at something absolutely fascinating, the biological destiny of the human body. We're going to uncover exactly how tissues break down, how extreme environments can completely rewrite the rules of decay, and how modern forensic science uses these changes to solve seemingly impossible crimes.
So, let's just dive right in with an incredible true crime mystery. Imagine a building contractor who's been missing for over 3 months. He is finally discovered out in a remote, extremely arid desert region. Now, based purely on that time frame, investigators expected to find absolutely nothing more than a scattered skeleton. But instead, they find a body with a remarkably intact exterior. So the big question we have to answer today is, how did this harsh, unforgiving environment completely halt the natural biological destiny of decay?
Picture this. Investigators get to the scene and discover a body with leathery, brown skin and, surprisingly, absolutely no putrid smell of decay. There's a complete absence of scavenging insects, too. But the most alarming part? When the forensic pathologist actually conducted the autopsy, a pristine, perfectly preserved stab wound was visible right on the left side of the chest, neatly penetrating the costal cartilage. It really forces us to ask how the elements literally froze the evidence in time to perfectly preserve a murder weapon's signature.
Section 1. Putrefaction, the classic pathway.
To figure out our desert mummy, we first have to understand the baseline biology of decay. The biological destiny of the human body basically relies on 2 primary processes. First up, we have autolysis. This is essentially self-digestion by the body's own internal enzymes, happening completely without bacteria. But the real heavy lifter in late decomposition is the second process, putrefaction. Putrefaction is bacterial decomposition. It kicks off when aerobic bacteria consume the remaining oxygen in the tissues. Once that oxygen is gone, anaerobic bacteria, most notably Clostridium welchii, which actually originates right in our own intestines, take over the whole process. Now, this classic putrefaction pathway follows very strict chronological steps. The absolute first external sign is a greenish discoloration appearing over the lower right abdomen, the right iliac fossa. Why there? Well, because it sits directly over the bacteria-rich cecum. In the summer, this can happen within just 12 to 24 hours. That leads into the second step, skin marbling, where the veins start to look a lot like floor marble. And finally, we see purge fluid. This is a blood-tinged, putrefactive fluid forced right out of the nose and mouth by intense gas pressure. A quick pitfall to note here, novices very often mistakenly identify this purge fluid as hemorrhage from trauma or poisoning.
What's really fascinating is the precise biochemistry behind that skin marbling. It is definitely not just random discoloration. The anaerobic bacteria, Clostridium welchii, secretes hydrogen sulfide gas. This gas then permeates the superficial veins and reacts directly with the hemoglobin in the decaying blood. This chemical reaction forms a specific compound called sulf-methamoglobin. It's this exact compound that has that dark green and black color, literally mapping out the superficial venous system right under the skin.
Okay, here is a massive clinical pearl, and honestly, a classic exam trap. If you ever see severe facial bloating, bulging eyes, and a tongue protruding past the lips in a decomposed body, do not immediately assume homicidal strangulation. In a heavily decomposed body, this is a completely natural artifact. It's simply caused by the immense pressure of putrefactive gases, things like hydrogen sulfide, carbon dioxide, methane, and ammonia, accumulating in the neck and chest and violently forcing the tongue upward.
Section 2. Saponification and natural mummification.
So what happens when the environment just completely interrupts this classic putrefaction pathway? Normal putrefaction, as we know, destroys evidence and injuries. But consider the alternatives. Adipose, also known as saponification, requires a moist, warm anaerobic setting, like wet clay soil. Here, bacterial enzymes turn subcutaneous fat into a firm, waxy armor. Then, on the other end of the spectrum, we have mummification. This requires dry, hot air with constant currents, which severely dehydrates the tissues into a brown, leathery state. The medical-legal value of both of these environmental exceptions is just immense, because they both beautifully preserve facial features and traumatic injuries for years.
Section 3. Maceration, the sterile pathway.
Let's flip the script and explore what happens to a body in the complete and total absence of bacteria.
Maceration is a strictly sterile pathway. Remember, standard putrefaction absolutely requires bacteria, but an intact amniotic sac is completely sterile. So, occurring only when a fetus dies in utero within an intact sac, the body undergoes aseptic autolysis. It essentially dissolves via its own digestive enzymes without any bacterial putrefaction at all, characterized mostly by skin slippage or degloving. Of course, if the sac were to rupture and vaginal bacteria entered, standard putrefaction would take over instead. The absolute radiological hallmark of this sterile maceration pathway is known as Spaulding's sign. This is the distinct overlapping of the fetal skull bones, caused by the liquefaction of the brain and the relaxing of those cranial ligaments. Clinically speaking, this is huge. If an obstetrician delivers a stillborn exhibiting this sign, it serves as critical clinical proof that the death occurred days prior to labor. This protects the medical team against any malpractice claims alleging that the death happened during the delivery itself.
Section 4. Timelines and organ decay. So, the surrounding environment dictates the biochemical pathway of decay, right? But it also dictates the specific speed. For that, we rely on Casper's dictum, which gives us the golden 1:2:8 ratio. This is a really striking way to visualize how incredibly protective different mediums are. The degree of putrefaction that happens in just one single week exposed to the air will take 2 weeks if submerged in water and a full 8 weeks if buried in soil. Air is the fastest medium, while soil is by far the slowest and most protective.
But even inside the body, the speed of decay isn't uniform. Here is a super high-yield rule to remember. Organs with the most water, blood, and enzymes decay first. Think of the larynx, intestines, stomach, and pancreas. Conversely, the tough, fibrous, and solid muscular organs resist decay the longest. The absolute last internal organs to decay are the prostate in males and the non-gravid uterus in females. That makes them incredibly vital for forensic pathologists who are trying to determine the sex of a highly decomposed body. And if we look at the absolute latest 2026 guidelines and evidence in forensic taphonomy, the science of time of death has evolved drastically. Instead of just relying on visual cues, forensic scientists can now swab a corpse to analyze the necrobiome, literally the microbiome of death. These bacterial communities shift in such a chronologically strict sequence that genomic sequencing can predict the exact postmortem interval down to a margin of mere hours, even weeks after death. It's a real game changer.
Section 5. Solving the desert mummy. All right, armed with all this high-yield knowledge regarding putrefaction, environmental mediums, and preservation pathways, we can finally solve our opening mystery. The missing contractor wasn't a skeleton because the intense heat, the total lack of moisture, and the constant dry winds created the absolute perfect environmental storm for natural mummification. The rapid evaporation of the desert actually beat the bacterial proliferation. The body fluids evaporated way before indigenous bacteria could even multiply to initiate putrefaction, essentially flash-drying the tissues into a tough, leathery shield. Because this permanently preserved structural integrity, that fatal stab wound was flawlessly maintained. The forensic pathologist matched the dimensions of that preserved wound to a specific hunting knife owned by the victim's business partner, securing a homicide conviction. Nature had literally locked the evidence away in a vault of sand.
Which leaves us with a truly chilling thought to end our explainer today. We have seen firsthand how the rules of biological destiny can be completely rewritten by the elements. So, if extreme environments can freeze time to perfectly preserve a murder weapon's signature and bring a killer to justice months later, what other dark secrets is nature hiding right beneath our feet, just waiting in the dust of time to be uncovered?